Hello again to my awesomeness and movies. This is a hardware debugging board for a PIC 12F 508. This is the board here, and I will explain to it. And it's hooked up to this PIC that is also hooked up to that PIC2 programmer. So let's see. What I did actually, I can show you both ways. Actually, I have a picture. Yeah, well, first of all, I've set up from normal internal RC. I set it up to LP, which it means low power crystal inside my program here. So oscillator LP instead of internal RC. This is a test program, and it's not that much of it. It's just I'm opening the second LED, and then I'm opening the first LED, and then loop again to the second LED, and then to first LED, and so on and so on. And it's looping forever. So this is the test program, and this is the circuit that I used exactly here. This is the entire circuit. I hope you can see. These are the two capacitors. Let me point with something. From here to here is to the minus, and from here to here is this crystal oscillator that is linked to the pins OSC1 and OSC2, and here that is OSC1 and OSC2, which are pin 2 and pin 3 of the PIC. So those white wires are going to the pin 2 and pin 3. Okay, so it's simple. This is actually the simplest oscillator, manual oscillator that I could that I make in the beginning, the first idea of how to do an oscillator, manual oscillator, to oscillate manually. Let me reset the device by taking it out with one hand and then insert it back. If I can, come on. I think it is, huh? Yeah, so it shouldn't open that LED. The thing, the problem with this button that I have here is staying on all the time in the middle. When I'm he got out. Come on. The problem, and when I'm clicking lateral, will turn off. Actually, now it's staying on, and probably that's why is yeah. So if I'm pressing a couple of times, let's number each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5, 6. 1. So as you can see, what I wanted to prove to you, this was happening a bit more worse than this. It was in my initial tests that I did, but it proved the concepts that I can manually switch and oscillate through the code of the PIC that is already programmed with that program that I showed you already. So pretty much I can do the connections. I can oscillate, but is not oscillating normally, because this button actually is bouncing, is creating a bouncing effect when is contacted. When the contact is made, is creating a bounce, and those oscillations of this button will trigger the peak will see as oscillations, those vibrations, very tiny vibration of the button when is contacted and when is not contact it. So when it's closed and when it's on, in the moment when it's on and when it's off, it's creating very tiny vibrations. And those vibrations are perceived by PIC as oscillator vibrations, and he is counting everything. So it's in other words, this is very random effect that I get with this tiny circuit. Let me take it out and show you, hopefully more in detail here, how it looks. Hopefully it will focus with the white paper. Yeah, and my button got out. 1 second to put the button back again. Come on. Sorry for this. This was not planned to get out. So it's exactly like in the schematic. This is how I made everything in this position. And yes, it's very basic. Do you have light? Yeah. So you see, and I think it's focused with one finger. Yes, now it's very focused. So this is pretty much how it's done, and it's very simple and very efficient, but it's very wrong because it's very random. And I will build another button with a 555 that will debounce the button. That will help the button not to be that sensitive. This is the circuit that I plan to make. So pretty much this is the button here. On all this circuit with the 555, the pin 3 of the chip is the output to in this case to a LED, but actually it will be to one of its pins of the PIC. Let's see here. We actually so you see, where are you? I'm not sure where this is saying here clocking, but I really want an OSC. Yes, I think this is it. Yeah, probably. So this will be the button, well, the output of that 555 to OSC 1 or OSC 2 pin. So to OSC 1 or OSC 2, to pin 2 or to pin 3 of the chip. Pretty much that's the idea that I actually, let's see if it say anything else. No. So yes, this is the idea, and this is what I will make next. And then further I plan to make a burst of impulses, not only manual. I will keep the manual as well, one by one pulse, but I will also, when I will press a button, it will transmit a pulse of 4 oscillations. As you can see, where are you? There. So for each line of code instruction, I will press and do everything by a single click. It will create 4 pulses for each instruction. Manually, I have to press 4 times for this instruction to be executed, and then to jump to the other one, the next one. Okay, that's it. I already explained too much in too much detail, and I hope I didn't forget anything. I hope you like it. This very simple what is called hardware debugging board. So it's a debugging for the code inside. Pretty much that's what is doing. All right. Thank you very much for watching, and see you next time. Hopefully. Bye bye.